History and discovery. The sulfur dioxide was discovered in ancient times and identified as a compound by Johann Becher. Carl Wilhelm studied its properties and called it sulfur air, while Louis Bartlett named it sulfur dioxide in 1796. Physical properties. It's a colorless gas with a sharp and irritating odor, similar to the smell burning. It has a density 2,926 grams edo and a molar mass of 64.06 grams mol. It's soluble in water and organic solvents, such as ethanol and ether. Chemical properties. It's an acid oxide that reacts with water to form sulfur acid. It's a strong reducing agent and reacts with many metals and organic compounds to form sulfates and sulfides. It's also a toxic and corrosive gas that can cause irritation to the eyes, skin, and airways. Common name and UPAC. Sulfur dioxide is the common name for this chemical compound, but it can also be called sulfur oxide 4. According to UPAC, the systematic name is sulfur oxide 4.
Description of the chemical bond present in the molecule. The molecule of sulfur dioxide meets the characteristics of a polar covalent molecule, which can be confirmed by the difference in electronegativity. This is sulfur with an electronegativity of 2.58 and oxygen with an electronegativity of 3.44. The difference between this is equal to 0.86. Remember that the electronegativity refers to the ability of an atom to attract electrons when combined with another element. When the electronegativity is less than 1.7, it is said that the bond is a polar covalent bond. This bond occurs when the atoms that interconnect have a difference in electronegativity, causing a region with a higher electron density to be generated, giving rise to a positive and negative pole.
To draft the Lewis model, we have to carry out 1. Count the valence electron in each atom, 6 valence electrons for sulfur and 12 electrons for 2 oxygen, for a total of 18 valence electrons. 2. Place the atom in the molecular structure. The sulfur atom is placed in the center and is the last electronegative atom, where the oxygen atoms are placed at the extreme. 3. Bond atom by sharing place of electron until a valence electron, which is used. 4. Keep in mind that each atom must function its octet. The very simple model of sulfur dioxide is obtained by placing sulfur in the center and position one oxygen atom to the left and another to the right. The band angle weighted to oxygen atom sulfur 190 degrees. It is prediction the geometry of molecule. It is based on repulsion bed atom. To know in molecular geometry, we must pay attention to H equals central atom, H equals atom attract to central atom. And the electron geometry of the sulfur dioxide is flat trigonal. The boring bond theory. When an atom combines a 2s orbital with 2p orbital from 3 sp2 orbital orbit, with each formation, we name the sulfur dioxide as sp2 hybridization. Sulfur dioxide completes its orbital by sharing electrons with sulfur and oxygen, forming 2 sigma bonds.
Describe the type of intermolecular forces that participate in the molecule. Due to the polarity of the sulfur dioxide molecule with a partial positive charge on the sulfur atom and 2 partial negative charges on the oxygen atoms, an attraction is produced between adjacent molecules, known as dipole-dipole forces. This force is weaker than covalent bond that joins the atoms with the sulfur dioxide molecule. Therefore, the intermolecular forces that participate in sulfur dioxide are van der Waals forces, specifically the dipole-dipole force. We can confirm this by analyzing the polarity, geometry, and molecular mass of sulfur dioxide. As polar molecules have an uneven distribution of electrons and generate electric dipoles, nonpolar molecules do not generate electric dipoles. The intermolecular forces of dipole-dipole and van der Waals forces are present in polar molecules, while London dispersion forces are present in nonpolar molecules. The way in which the atoms are arranged in a molecule can affect the intermolecular forces. For example, molecules that have a linear or planar structure can have stronger dipole-dipole forces than molecules with three-dimensional structures.
Uses and applications. One of the most important applications of sulfur dioxide is in the production of sulfuric acid. In the processed food industry, it is used as a food preservative and a stabilizer, as a moisture control agent, and as a flavor and texture modifier of certain edible products. It is also used to sanitize equipment that comes into contact with food. Fermentation equipment such as those in breweries and wineries, food containers, etc. In petroleum refining to trap oxygen and retard corrosion. Environmental impact. Damage to biodiversity. It causes damage to the vegetation, degradation of chlorophyll, reduction of photosynthesis, and the consequent loss of species. Damage to health. Irritation and inflammation of the respiratory system, pulmonary condition and insufficiencies. Alteration of protein metabolism, headache, or anxiety.